If you're still tweaking RAG prompts by feel, you're doing search and replace, not optimization. DSPy lets you tune against a metric that actually matters. This is the workflow you'll know how to run when we're done, which tunes retrieval and prompts using labeled checks, and then reports the metric score. I'm Professor Pi, teaching AI engineering and LLM systems with simple Python. RAG tuning is a workflow problem. You have a retriever, a prompt, and a set of labeled checks. People often tweak prompts by intuition and hope for the best. That works for tiny demos, but it does not scale. Success looks like a reproducible gain on a metric you care about, not just prettier answers. DSPy is built to bridge that gap. It turns prompts and retrieval into measurable modules you can evaluate and optimize. At a high level, DSPy gives you a way to define what the model should do, run that program across examples, and score the results with a judge. Then, you can search for better prompts or demonstrations guided by that score. Think of it as a small experiment engine. We will use a tiny corpus of 3 factual sentences and 2 labeled question-answer pairs to keep the ideas clear. That keeps latency low and results easy to inspect. We will build a miniature RAG pipeline. First, we measure a simple hit rate with raw retrieval. Then, we wire in DSPy to prompt an OpenAI model with context. Next, we evaluate end-to-end with a simple judge. After that, we run DSP's teleprompter to BootstrapFewShot demos and compare scores. Finally, we record runs and pick the best configuration. The goal is a measured improvement on the same labeled dev set before and after optimization. First, we'll set up the tiny corpus and compute a simple hit metric. This snippet builds a miniature corpus and computes a simple hit rate for a question-to-document match. The variable docs holds 3 short factual sentences, and eval set contains 2 labeled question-answer pairs. The expression inside ACC uses token overlap to score each document for a given question, selecting the highest scoring document with max. It then checks if the gold answer string appears in that chosen document, summing successes and normalizing by the dataset size. The small scoring routine is intentionally transparent, so you can inspect how terms affect retrieval. The printed hit rate shows how often the top document alone contains the answer. Next, we'll wire DSPy to an OpenAI model and run a grounded generation. This example configures DSPy with an OpenAI language model and wires a minimal RAG call. The class RagQA defines a DSPy signature with a question, a context, and an answer, which tells DSPy how inputs map to outputs. The object QA is a DSPy predict module that prompts the model according to this signature. For a quick smoke test, it calls QA with the first question from eval set and a naive context formed by joining all docs. DSPy handles formatting the prompt and parsing the answer into pred answer. The printed answer confirms we can generate a response grounded in the supplied context. Now, we'll run a labeled evaluation across the small dev set. This code measures how well the DSPy program answers questions against labels. The list dev set packages each example with a question, a joined context from docs, and the expected answer. The function judge is a simple metric that checks whether the model's answer contains the gold answer string, returning a Boolean score for each case. The DSPy evaluate object runs QA across the dataset, aggregates the metric, and returns an overall accuracy. You can add more examples to DevSet to make the estimate more stable. The printed accuracy quantifies today's quality, so changes can be tracked over time. Next, we'll optimize the prompt with DSPy's BootstrapFewShot teleprompter. This snippet uses DSPy's BootstrapFewShot teleprompter to optimize the RAG prompt against the judge metric. The object tele learns helpful FewShot demonstrations from the trainset devset and then compiles an improved module with tele.compile. Producing improved. The evaluation EV2 reruns the same judge metric on the same devset, so you can compare apples to apples. Increasing max bootstrapped demos generally explores more candidate demonstrations at the cost of more model calls and latency. Decreasing it speeds up optimization, but may reduce quality. The printed accuracy shows the optimized prompt's performance, revealing whether the teleprompter delivered a measurable gain. Finally, we'll log runs and pick the best configuration by score. This snippet records 2 experiment results and selects the best one by the same evaluation metric. The list runs holds a baseline score from the original DSPy module and an improved score from the teleprompted module. The variable best uses max with a key function reading each run score, ensuring a deterministic pick even if runs grow later. In a team setting, you can extend runs with timestamps, model names, and prompt hashes to make comparisons fully auditable. The printed best run and score make the winning configuration visible, anchoring future changes to a clear, measured improvement. In a real project, that pattern scales. Replace the tiny docs with your knowledge base, and replace the small dev set with a labeled test set that matches real queries. The pipeline stays the same. You still measure on the same labels. You still optimize prompts against that metric. And you still pick the configuration that improves the number you care about. Recap. DSPy lets you turn prompt and retrieval choices into measurable experiments. Use it when you need real improvements on labeled questions, not just prettier outputs. One caveat: the optimization needs representative labels, or you risk overfitting to toy checks. Wrap punch. Next, tune the max bootstrapped demos parameter to trade off latency and exploration, and watch the judged accuracy change. If practical, repeatable AI engineering helps you ship better models. Subscribe and watch the AI engineering videos.